All right, right angle trigonometry, finding the sine, cosine, and tangent ratios. So we have a triangle here on the right, and we've got the side lengths that are identified. We have measures of side lengths, and we have a triangle. Let's say we're going to call this JLK. And we're asked to find the sine J, cosine J, tangent J, sine K, cosine K, tangent K, express each ratio as a fraction and as a decimal to the nearest 100th. All right, I advise strongly that anytime you're dealing with right angle trigonometry, let's write our acronym at the top of your paper. So, TOA. So the sine is the opposite over the hypotenuse. So the cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. So we got a right triangle here. Number one, let's locate the hypotenuse, which is directly across from the right angle. So our hypotenuse is 13. Now, we're looking first at the angle J, and we're going to find the sine, cosine, and tangent. Now, sine is opposite over hypotenuse, and so the side opposite angle J is 5. So the sine of J is just simply 5 over 13, the hypotenuse. Now, if we want to get that in decimal form, I just go to my calculator, put in 5 over 13, rounding to the nearest hundredth, and that is approximately equal to 0.38. All right, cosine of J. Well, the cosine of J, COA, is the adjacent side over the hypotenuse, and the adjacent side of J is 12. So, adjacent over hypotenuse, 12 over 13. And again, if we're going to put this into decimal, I'm just going to hit 12 divided by 13. And, well, hit the wrong button. Menu, two numbers convert to decimal. 0.92. And then lastly, for angle J, we're going to find the tangent of J. And the tangent is the opposite TOA, tangent opposite over adjacent. We've already determined that the opposite side of J is 5, and the adjacent side is 12. So we got 5 over 12, and let's get that to the decimal rounded to the nearest hundredth. 5 divided by 12, and that would be 0.42 when I round that. Okay, 0.42. Well, there's sine, cosine, tangent of J. Now let's work on sine, tangent, cosine of K. Well, I already know my hypotenuse. It's not moving. It's staying the same. It's still 13. But my opposite and adjacents are going to change since we're looking at a different angle. So the sine of K, again, sine is opposite over hypotenuse. And the opposite side of K is 12. So it's 12 over 13. And that's going to be approximately, rounding to the nearest hundredth, 0.92. All right, cosine of K. Cosine, we know, is adjacent over hypotenuse. Well, the side adjacent to angle K is 5. Hypotenuse is 13. So we've got cosine of K is 5 over 13. And that is approximately 0.38. And then lastly, the tangent of K. So tangent, TOA, TOA. Tangent is opposite over adjacent. Well, the side opposite K is 12. Side adjacent to K is 5. So this is going to equal 12 over 5. And let's see what that is approximately. 12 divided by 5. Boom, 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 boom. 2.4. In fact, it actually equals 2.4. All right, well, there we go. We have found sine, cosine, and tangent ratios of two angles in a right triangle. You just got to love it. And if you don't, tough luck.